Good morning, students. Today we are going to solve question number 17 of exercise 10.3. Here the question is, so that the vectors 2i cap minus jk plus k cap and second vector I cap minus 3j cap minus 5k and the third vector components are 3i cap minus 4j cap and a minus 4k cap form the vertices of a right angle triangles. Stanong on the vectors ahum pireba. Vector ahum sina right angle triangle amagi vertex ne na so tawdoni ko. Question number 17 important question hai. First draw a triangle ABC. Let the position vector of A be the first vector, position vector of B the second vector, and position vector of C be the third vector. A, B, C have a say nangi given vectors to the position vector nena laureko. Then find the three sides. Say A, B vector, B, C vector, and the C, A vector. Nangi triangle ahum segi side ahum se lower se. A, B vector which is given by position vector of B minus position vector of A. Write the components of OB vector, components of OA vector, and subtract their corresponding components. 1 minus 2 is equal to minus 1, minus 3 minus minus plus minus 2j cap, and the 5 minus 1 is equal to 6k cap. Then find BC vector, which is given by OC vector minus OB vector. Write the components of OC vector and components of OB vector. Here OC vector is 3i cap minus 4j cap minus 4k cap, and components of OB vectors are I cap minus 3j cap and a minus 5k cap. By subtracting the corresponding components, we have 2 minus 1, 3 minus 1, 2i cap minus 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 plus minus 4 plus 3 is equal to minus j cap, and the minus 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 plus minus 4 plus 5 is equal to k cap. Similarly, we can find this CA vector. If CA vector is given by position vector of A minus position vector of C. Subtract down minus I cap plus 3j cap plus 5k cap Then find the scalar product of any of these three sides. Nangi side ahum segi side ani scalar product lauren. Howsing nang natawduse kaino scalar product of any of the two sides ni ko. Scalar product lo se ahanbada AB vector dot BC vector. Write the components of AB vector and write the components of BC vector. So my ito scalar product of two vectors in terms of their component is equal to sum of product of corresponding components. Minus 1 into 2 is equal to minus 2. Minus 2 into minus 1 minus minus plus minus 6 plus 1 is equal to minus 6. The cancelling plus 2 and minus 2 we have minus 6. Here the scalar product of two sides, AB side and the BC side is equal to minus 6 Then find the scalar product of BC and CA. Components of BC vector, components of CA vector. Then find their scalar product. 2 into minus 1 is equal to minus 2, minus 1 into 3 is equal to minus 3, and 1 into 5 is equal to plus 5. Minus 2 plus minus 3 is equal to minus 5, minus 5 plus 5 is equal to 0. Kigi BC ga CA ga scalar product is 0 sale, which implies that this BC vector is perpendicular to kanada perpendicular oigani. CA the perpendicular remaining simulaw AB vector dot CA vector. Write the components of AB and write the components of CA. And see their scalar product is equal to minus 35 0 tadreba. Nangi sigi triangle ABC gi manungda side ahum sigi manungda side ani aina scalar product lobo matamda BC side siga CA side siga gi scalar product is 0 fangi, which implies that this BC side is perpendicular to kanada perpendicular tagani. B, C, A have a kanda. Nangi BC side say CA is the perpendicular or the triangle ABC is a right angle and right angle at Canada or C da do nanangi ABC have a vertices of a right angle tare ko do nanangi ngasai vectors ahum p was at any right triangle amagi vertex loy or therefore triangle ABC is a right angle triangle at Kanadway ba C the kwa. Silore question number 17. Here next question. Next question is question number 18. If a vector is a non-zero vector of magnitude A and the lambda is non-zero scalar, then lambda a vector is a unit vector if haraga there are 4 options, option A, option B and option D. Here we have to choose the correct option for this case. Correct option choose tawduni ko nangonda vector sampir. There is a vector of magnitude A. A vector sigi magnitude se A ni and the lambda is not equal to 0. Lambda not equal to 0 se ni any scalar oidoini ko and lambda a vector is a unit vector. That is magnitude of lambda a vector will be equal to 1. 1 phangi ko. Lambda a vector gi magnitude se nahan kai gamana gi magnitude of lambda and the magnitude of A is equal to 1 modulus of lambda ito magnitude of A di 1 tareko which is equal to 1. Here A value of A is equal to 1 divided by modulus of lambda. Understand nangi option se first lambda equals to 1, second lambda is equal to minus 1, third A is equal to modulus of lambda, fourth A is equal to 1 by modulus of lambda. Nangi correct option se option D se tareko. Next topic is vector product of two vectors. China last part ni nangi vector haiba chapter se gi ko. Vector product of two vectors ki magi definition, observation and my some applications te loidoine. Then now let's define vector product of two vectors. Vector product se kai haraga su khangnai, cross product haraga su khangnai ko. Cross product of two vectors haraga su koina inai. The vector product of two non-zero vectors A vector and B vector is denoted by A cross B and is defined as A cross B is equal to magnitude of A, magnitude of B, sine theta n cap. Magnitude of A, magnitude of B, sine theta n cap nika, where theta is the angle between A vector and B vector lying between 0 to 180 degree. 0 to pi. 0 dagina 180 bogi marakta lebe angles niko and n cap is a unit vector which is perpendicular to both A vector and B vector. N cap haibase vector ramani unit vector ramni ko kana the perpendicular oiba which is perpendicular to the plane of vector A and the vector B. So that A vector, B vector and n cap se right-handed system neba rotating from A to B and in the direction of n cap. A dagi B da chatkani aduga kadom da chatpoi gadaba n cap da chatkadaba right-handed da labor akoina right-handed da labor system of neba A vector ga B vector ga kanaga n cap ka ko A dagi B da chatkani B dagi n cap da chatlani sumain tara akoina A vector cross B vector se define ta where. But in case of B cross A haitara di kamai irani magnitude of B, magnitude of A, sine theta haibama. B dagi na A day la. This is a right-handed system am tagadam neba. B dagi A da chatlaba. Adudi A dagi atopa vector am da chattuini ko. But this vector is opposite to kanada opposite oi n cap da. N cap da opposite oi taragadi negative sign haina lakani ko amagi negation ni. Amana som da chalaba. Amana som da chatardi animak se opposite da lainaba kawe opposite oi tardi negative sign ama koina p neba opposite direction na chatpase ko aduna A vector cross B da di n cap hoiba kana B vector cross A da di kai tarani minus n cap haineba B cross A se definition gi matungina magnitude of B, magnitude of A, sine theta and minus of n cap, where this n minus n cap is a vector which is perpendicular to both A vector and B vector and B vector, A vector and minus n cap form a right-handed system rotating from B vector to A vector and in the direction of karigi direction na chatkani minus n cap tandak na som da lakani ba my direction je ko aduna minus sign am yaurani. Therefore A vector cross B vector is not equal to B vector cross A ani se manade ba. Ani se manadaba means vector product se commutative oide ko. If either A vector or B vector are zero vectors, nangi vector ani dugi manungda ama zero oitaragadi then their cross product will be equal to 0. Then how se koina vector product or cross product se define to bahirani ko. Vector product or cross product is defined as A vector cross B vector hierarchy magnitude of A, magnitude of B, sine theta and n cap, where this theta is the angle between kana-kanagi marakta laiba A vector and B vector. Lore ko next. Observations. A vector cross B vector is a vector. Cross product of any two vectors a vector amniko. Maram kaigino hai tardi ngasai magnitude of E is a scalar ni, magnitude of B is a scalar ni, sin theta scalar ni, but this n cap is a vector amni. Unit vector suma vector ramani aduna. Cross product of any two vector is a vector. Roman number 2. Let A vector and B vector be any two non-zero vectors. Then A vector cross B vector equals to 0 if and only if A vector and B vector are parallel. Parallel oitaragadi theta se 0 natraga pi taneba. Parallel oiba matamda nangna vectors ani se parallel already 0 or pi. If the two vectors have the same direction, then theta will be equal to 0. And if the two vectors are in opposite direction habadi magi maikai se onana chatpa matamda theta se pi launeba ko nangi both case da sin 0 so 0 ni sin pi se 0 ne duna A cross B की value से 0 vector tane if and only if karam kanda A vector is parallel to kanada parallel already B vector ko. In particular, A vector cross A will be equal to 0 vector and A vector cross minus of A will be equal to 0. Chamanaba vector ani the cross product law was 0 chatkani magi negative ka lower ga sukai chatkani 0 chatni. Number 3. For mutually perpendicular unit vectors I cap, j cap and k cap, mutually perpendicular unit vectors main angle between any two of these three vectors hai. Nangi I cap oigera j cap oigera k cap sigi moi ahum sigi angle se 90 loin laigadamne ko I cap, j cap and k cap se 90 ngatane. 90 oibene mutually perpendicular unit vectors hairese, and we have I cross I, j cross j, k cross k will be equal to 0 vector and I cross j staying siko. Definition iro magnitude of I, magnitude of j. Then find a unit vector which is perpendicular to both I cap and j cap, and I ga j ga da chamanana perpendicular oiba animakta perpendicular oiba unit vector ama hairagadi k cap tareba, since magnitude of I1, magnitude of j1, and so 1 into k cap will be equal to k cap. I cross j is equal to k and j cross k will be equal to kai delakani I delakani ko. Duna sigi se khangnaba khuna cyclic relation am khalase. Let us consider a cyclic relation among the three vectors I cap, j cap, and the k cap in anti-clockwise direction. Anti-clockwise the logadaba ko. Aduna na ngasai da I 0 secre, j 0 vector, k 0 vector thare ko. Manadaba ani the loragadi I cross j will be equal to k. J cross k will be equal to I, and the k cross I will be equal to j. Kaida loragadi anti-clockwise direction the loragadi ko, but nang na clockwise ta chalaba, clockwise ta chalagadi negative sign in lakani ba. J cross I, j I halaga chatle ko clockwise ta la e doi tardi mamang the minus sign am hapkani ba, and the j cross k cross j kj halle ko my rotation chidagi the minus sign am hapani I k haragadi minus j dala ani ba. Anti-clockwise oragana positive, clockwise oragana negative hapkani ba ko. Then observation number 4. Observation: vector product is not commutative. Vector product is not commutative, that is mamang the inang aside definition ko. A vector cross B vector not equal to B cross K, but A vector cross B vector is equal to minus of B cross A. A ga B ga se nang na position si interchange tawba pama ba. Adoi tardi mamang the kay sign hapakani minus sign am hapakani ba. Observation number 5. If A vector B vector represents the adjacent sides of a parallelogram, then its area is given by. Nangi A vector ga B vector ga sina parallelogram amagi adjacent sides represent utaragadi area of the parallelogram is given by magnitude of A cross B na P ni ko. Kamay P ni haitaragadi hoseyang ase. Let us consider a parallelogram ABCD, and this side AB is represented by B vector and side AD is represented by A vector. Then draw DE. Draw DE which is perpendicular to AB, and the DAB is equal to angle theta sigamana halle ko. The parallelogram ki area se kaina P haragadi kaina P re area of the parallelogram is given by base into height. Base into height. Here base is equal to b and the height is equal to dA. So this AB is denoted in vector form as magnitude of AB vector and this DE. In a right angle triangle DAE sigi manungda DE is opposite to theta and AD is the given sine ko, and so this DE is replaced by kaina replaced over yarani AD vector magnitude into sine theta. Habidi theta gi opposite lebagi ko sine theta. AB vector is represented by magnitude of B, then this AD is represented by magnitude of A and sine theta. Then we can interchange magnitude of A and magnitude of B. Magnitude of A, magnitude of B sine theta. Si kanagi formula tare, which is the magnitude of A cross B. Sagi A cross B gi definition da ko. Magnitude of A, magnitude of B sine theta into n cap neba. Tida ina modulus loksin taragadi. Modulus of n cap haiba kanda my value se kya tagrani 1 tagrani ba sigi n cap se katani ba ko n cap se nang 1 lakrani duna magnitude of A cross B haiba se kai ga manani magnitude of A magnitude of B into sin theta haiba se kaktang do intarani ko magnitude of A magnitude of B sin theta is equal to kai ga manare magnitude of A cross B tare ko. Next observation number 6. If A vector B vector represent the adjacent sides of a triangle, then its area is given by nasagi parallelogram sigi adjacent side ani sa vector ani na represent taram taragadi area of the parallelogram se cross product lorga magnitude lobane ba handang na kai dala aba triangle de laba ko triangle amagi manungda magi side ani se piragadi area of the triangle se kai ga mane heba half magnitude of cross product of two vectors haibani ko two vectors say any two sides na represent tawgrasu yadoini aduna in a triangle ABC here AB side represents A vector AC side represents B vector and draw CD. CD is altitude ni ko CD is the altitude on the side AB see the perpendicular tarani and theta is equal to CAB see uhele. Therefore area of the triangle ABC. Area of the triangle ABC is equal to half base into altitude. Here base is AB and the altitude. Altitude is equal to CD. This is AB vector expressed the magnitude of AB vector and this CD. CD is the opposite of the angle theta in right angle triangle ACD. Right angle triangle ACD sigi manung the CD have a side se theta sigi opposite or and AC side se kainoma se hypotenuse ni ko given ne aduna this CD can be represented by kanana represent or magnitude of AC vector into sin theta and half magnitude of AB is magnitude of A then is AC. ACD kaina represent or B and sin theta ko and this expression is represented by magnitude of A vector cross B is minor represent of wherever duna koina area of the parallelogram hardi vector rani do cross product lorani magnitude lorani area of the triangle haragana half hapa ni ko. Next property number 3, distributivity of vector product over addition. Distributive law ni ko if A vector B vector and C vector are any three vectors and lambda be a scalar then ahanba law se kaino A vector cross B vector plus C it will be equal to A vector cross B plus A vector cross C se distributive law ko distributive law se kana cross product ta apply to where Roman number 2, lambda A vector cross B. Sikai de la ino haradi A vectors the lambda am hapaba. Lambda A vector cross B vector or A vector cross lambda B vector is same as kanaga chamane lambda A vector cross B siga chamane koina vector product logo the scalar yaude ko. Next topic is vector product or cross product of two vectors in terms of their components. Components that layram taragadi. Component means if the two vectors are given in terms of ijk, then how to find the cross product of two vectors? I have a question to say. Let A vectors components are A1 I cap, A2 J cap, and A3 K cap. and B vectors are, B vector is B1 I cap plus B2 J cap plus B3 K cap. B any two vectors minus ng vectors ani pire ko. Then we are going to find A vector cross B vector in this form. First write all the components of A vector, then write all the components of B vector. Mamangda ina scalar product lobudassu concept khara haigre ko. Nangna state tawduse kaino sigi first term se. First term siga B vector siga scalar dot product logo cross product logo. Then second term siga muglogani, third siga muglogani ko. First find the scalar product of A1 I cap with the components of this B vector, B1 I cap plus B2 J cap plus B3, plus write second component A2J cross product of simami toeka, write third term 0 A3K cross B1 I cap B2 and B3 simai toe. First ki sanning siko A1 B1 real number ni A1 B1, find the cross product of I plus A1 B2, find the cross product of I and J. A1 B3 product cross product of IK ito ko cross product of second gi A2 B1 JI plus matang the A2 B2 JJ A2 B3 JK last term A3 B1 cross product of KI A3 B2 cross product of KJ A3 B3 cross product of KK. As I observations to go from the observations of cross product of two vectors I, JJ and KK would be equal to 0 vectors. 0 vector taranip sa manavadi 0 chalidan. A1 B1 0 vector, A1 B2 IJ will be equal to KK, A1 B3 IK and clockwise it will be equal to minus JK plus A2 B1 minus KK plus A2 B2 JI minus K dahan ko si 0 sa last ki A2 B3 JK di JK se kay gamanarani I gamanare ko A3 B1 dum ito KI is equal to J A3 B2 KJ clockwise tahalle ko clockwise taladi minus sign am hapo A3 B3 KK will be equal to 0 vector I cap yawa khanchi ko I cap si sidama yawre topa mas de yawre plus han ito A2 B3 minus A3 B2 minus sign second ki J ki the GM layer, the GM layer ko minus common log to do the A1 B3 plus minus common log the minus pangani A3 B1 JK plus first find the components of KK first dam layer ko plus yan ito A1 B2 minus A2 and B1 ire ko sige expression se kay gamana ni this expression is equal to expansion of a determinant whose elements are I cap, J cap, K cap. A1, A2, A3, B1, B2, B3 is my lang ni I, A2, B3, A3, B2. Tari ko matang the J kuna determinant expansion the plus sign chal. Minus J, A1, B3 and A3 and B1 si fange ko K cap, A1, B2 and A2 and B1 chumain. Tiki se fange duna ka sida kuna kangaw du se kay no. Cross product of two vectors in terms of their component is equal to expansion of a determinant. Determinant na magi expansion gamana ni aduga nang elements se kamay gani. All the elements of the first row will be I cap, J cap and the K cap. Then write the components of A vector and write the components of B vector. Ahanba vector sige component irani mathang da ani subasige mo component ito ani ko. Example. If there are two vectors, A vector and B vector, component form the pair, find A cross B. A cross B is equal to expansion of a determinant whose elements are I cap, J cap, K cap. A vector, write the components of A, 1, 2, 3. Then write the components of B, minus 1, 1 and 2. Expand the row. Expand this determinant along first row. We have I cap, find the determinant obtained by deleting first row and first column. We have 2, 3, 1, 2, 2, 2, 4, 1 into 3, minus 3. Sign convention gi minus am lakjarani ko. J gi mapaka se 1 into 2 is 2, 3 into minus 1 is minus 3. Minus minus plus last ki k kyaf. K gi mapaka eko 1, 1 is equal to 1. 2 into minus 1 is equal to minus 2. Formula ki minus amaga plus tare. Then is the vector rampangi ko, and cross product of any two vectors is a vector. Next example 22. Find magnitude of A cross B. A cross B की magnitude होती है का if magnitude of A 2 I cap J cap and if vector A vector B सुमाइन पिथो है. Housing नंग न पुथोक तो इसे कहीं न magnitude of cross product of A B नि को आदुना कोई न first कहीं पुथोक कनी here we are going to find A cross B. A cross B is given by expansion of a determinant. Determinant amagi expansion na p ko amagi elements se ijk fix ne. Then write the components of A. Components of A are 2, 1, 3. Then write the components of B 3, 5 and minus 2. Expand the array. By expanding this determinant along first row we get A cross B is equal to a vector whose components are minus 17 I cap plus 13 j cap and 7 k cap. Then find the magnitude of A cross B, which is equal to x component square plus y component square plus z component square. And here x is minus 17 whole square, y is 13 square, and z is equal to 7 square. Minus 17 whole square is 2 and 9, 13 square is 169, 7 square is 49, and their sum is root over 507, which is the magnitude of cross product of AB. For today, let's end here.